We're revisiting an example we did earlier, which was actually example 6.4.3, where we had summary stats from Heat 2 and Heat 5 of the Olympics. So we have the means and standard deviations and sample sizes here, which were both 4. Instead of doing a confidence interval like before, we wanted to conduct a test to see if there's a difference in the average finishing times for the 2 heats. And then we're asked if these findings for this test agree with the confidence interval that was already constructed. So we're looking for a difference. So our null hypothesis will be that the difference in the means is 0, or in other words, the means are the same. And then our alternative is that the difference is not 0, or you could also write that as mu1 not equal to mu2. Our test stat will be the difference in the 2 sample means divided by the square root of the 2.23 squared over sample size of 4 and 1.38 squared over sample size of 4. This produces a pretty small test stat of negative 0.168. Degrees of freedom will be 3. It's the smaller of the two n's minus 1, and those are both going to produce 3 because they're both 4. We're doing a two-tailed test since it's not equal to. So when we go to stat key and we put in our t distribution, degrees of freedom 3, and then we will click on two-tail since we're doing a not equal to. And then our test stat, we'll put on the negative side here, was negative 0.168. And so you can't even quite read it, but each of those two tails is a 0.439. So our p-value is 2 times 0.439, which is a very large number, 0.878. So we definitely would fail to reject the null here. That's definitely greater than 0.05. So we'd fail to reject the null. And what we would say then in conclusion is that we do not have evidence of the alternative. So we do not have significant evidence of a difference in the population mean finishing times for the 2 heats. And this does match the confidence interval conclusion because our confidence interval contains 0, which suggested that there was no difference.